Hey, it's you again. And it's me again, and let's keep on keeping on. Still working in Unit 7, Lesson 5 this time. We are going to begin the amazing process of factoring. Factoring polynomials. And there are many, many ways we're going to learn how to factor polynomials. We are definitely inching closer and closer to factoring quadratics. But, I mean, are we technically going to be factoring quadratics today? Yes, but we're not really going to call them that yet. But so one of the major parts of our curriculum at the end of the year in fourth quarter is quadratics, equations that have a specific format. And we're definitely just moments away from arriving there. And learning how to factor a polynomial is key. So it's super duper important you understand this lesson. It's super important that you do well on the independent practice in order to have a really solid base to build upon when we start to tackle some quadratics here real soon. So factoring polynomials using greatest common factor. That's probably the only time you're going to hear me say that exact phrase in this lesson. I tend to come up with my own little sayings, and what you're going to hear me say more than anything is, can you factor anything out? So you're going to hear me say it like a gazillion times. Can you factor anything out? What can you factor out? What can you divide out from both of those or all of those terms? So this is not something I talk about a lot, this GCF, but you're going to hear me use my own version of it. So again, once we get some of the notes down, you're going to see that I'm going to switch to lined paper because otherwise it just gets super blurry. All right, starting off with factoring polynomials. They want to do a quick review of like multiplying and distributive property, so let's run through that quick because ultimately, well, I'm getting ahead of myself. Let's just review. They want us to review, so we're going to review. Do you remember how to take A times the quantity or the sum of, like, in this case, 3a plus 7. So you're taking a little monomial times a binomial here. It's just a distributive property. What's a times 3a? That would be 3a squared, right? You're taking this outside guy times the inside pieces. And what's a times a positive 7? That's a positive 7a. All right? And we can move down, and now we have a trinomial in parentheses, and we're multiplying by negative 2m. So negative 2m times m squared is negative 2m to the third. Negative 2m times a positive 6m, that would make a negative 12m squared. And a negative 2m times a negative 1, negative times negative makes positive 2m. So we're just kind of reviewing the multiplying part. And a little bit longer here. We add in some other variables. 5xy times another x. That makes 5x squared y. And 5xy times a negative 2y. Well, what's 5 times negative 2? That's negative 10. xy with another y is xy squared. So they just want to remind you how to simplify those problems. So now, what is factoring? Factoring is when you take a polynomial and you break it down into its smaller products. So you're going to start with something that looks like this, and we're going to turn it into something that looks like this. Or you're going to start with this, and you're going to go this direction. Or you're going to start with this, and you're going to go this direction. So factoring is like the reverse of what we just did. So what is factoring? The process of, I'm going to say, breaking down a polynomial into a product. you're going to hear me say, what can you factor out? Okay? Now, sometimes you'll see a polynomial that cannot be broken down. There's nothing that can factor out. There's nothing you can take out of all the terms. That is called prime. Those don't happen very often, but they are out there. They do exist. Okay. Here it says, there will be several ways to factor. The approach we will take depends on your polynomial. Today, we will start by using greatest common factor of the polynomial. In other words, I'm going to ask you to think of what is the biggest number and what are the most variables that you can factor out of each piece of the polynomial. You'll see what I mean here in just a second. Let's start with this one. Start with 3x plus 12. Now, focusing first on the 3 and the 12. What can you divide them both by? Or what would be a factor of 3 that is also a factor of 12 if you were to break them down into their factors? Well, the factors of 3 are just 1 and 3. Factors of 12 are 1 and 12, 2 and 6, and 3 and 4. So you got to find the greatest common factor. Ugh, I hate that. That whole phrase just does not, I don't like that. My brain doesn't think that way. My brain thinks of what is the biggest number I can divide out of a 3 that I can also divide out of a 12. And that answer is a 3. So you factor out a 3, or you divide out a 3, and you put it out here on the outside of parentheses. Now, this guy has an x. This guy does not have an x. That means you cannot factor anything else out. Now, let me just tell you, if the 12 did have an x, and they both had an x to give, you could factor out an x, and you could put an x out here, but we can't. So, in this case, if you divide a 3 out of 3x, that would leave behind 1x, and if you divide a 3 out of a positive 12, you get a positive 4. Basically, what you're doing is undistributing, right? That's another way to say it, and that's it. This is your final answer. You have factored a polynomial. It was a binomial, pretty easy one at that, but you did it. Let's do it again. Remember, when I number my paper like this is just because it helps me keep track of the examples that I'm using, because literally this lesson has 24 examples. We're not going to do all 24, but it is important for my brain that I keep track of which one I'm currently writing and working on. Let's do this one, 5x plus 30y. So you're thinking, what can I divide out of a 5 and a 30? What's the biggest number? You always want to take the biggest number, right? You can take out a 1, that's not going to change anything. The biggest thing that can come out of a 5 and a 30 is a 5. So you divide that 5 out. Now, could I take an x out of here? Yep. Only if you could also take an x out of here. Oh, he doesn't have one to give. So you cannot factor out an x. He's got a y, but he does not. So you cannot factor out a y. So they have to stay inside the parentheses. They get left behind. So all we're going to do is divide out the 5. That would leave a 1x and a plus 6y. Another way to write that would be without showing the 1, just like so. You know, it's that whole, do you show the 1 or do you not show the 1? Quite frankly, I don't care. However you prefer. Let's do another one. What can come out of a 6 and a 27? The biggest number that can come out is a 3. He's got 2 a's, he's got none, so no variables come out. What does that leave behind? If you divide out a 3, that leaves a 2a squared. And if you divide out a 3, that leaves a positive 9. You're undistributing. That's it. You factored it. You can't do anything else. Let's do one where you can give a variable. Let's do 7. We start with 21CD and a minus 3D. Now, What can come out of a 21 and a minus 3? Do not worry about the fact that that's negative. We'll definitely talk more about things like that later, but for now, just don't worry about like factoring out a negative. No. For today, everything we're going to factor out is going to be a positive, okay? So what can come out of a 3 and a 21? A 3 can come out. He has a C and a D. He has a D. Uh-oh, they actually have a D that they could both give, right? You can divide a D out of here and a D out of here. So because both pieces have a common variable, you can pull the D out. You can factor it out. What would that leave behind? Well, if you took a 3 out of 21, that would leave behind a 7. You took out the D, so that would just leave behind the C. Okay? If you take a 3 out of negative 3, that leaves a negative 1. And it had a D, but you took it out, so you're left with that. And guess what? If you were to redistribute this, if you were to do the multiplying, you'd end up right back here. In fact, if you want, I'll prove it to you. If you don't want, you can fast forward this part. Let me show you what happens if you distribute. What is 3D times 7C? It's 21CD. What is 3D times negative 1? Negative 3D. And isn't that exactly where we started? Yup. Okay, cool. Undistributing. Let's dial it up a notch. Blah, blah, blah. Da, da, da. Ooh, I like 13. Lucky 13. Here we go. It's 18. Hang on. Let me turn the page so I can, A squared B C squared minus a 48 A B C, and the C is to the third power. Okay, coefficients first. What can you take out of an 18 and a 48? Again, think the biggest possible number. Biggest possible number that can come out of an 18 and a 48 is a 6. A2 and A. Well, how many A's can I take? He's got 1, he's got 2. That means I can only take 1 out. He's only got 1 to give. So that's the most A's you can pull out of both. We're going to take 1 A out. He's got a B, he's got a B. We can take a B out. 2 C's here, 3 C's here, which means we can take these 2 and we can take 2 of those. So C2 comes out. What gets left behind? Well, here we go. If you divide a 6 out of an 18, that leaves behind a 3. He had 2 A's, we took 1, leaves 1 A behind. He had a B, but we took it out. And he had C2, but we took it out. So all that's left behind when you factor this is a 3A. Now we move on to the second half. If you divide a 6 out of a negative 48, that leaves behind a negative 8. He had an A, we took it out. He had a B, we took it out. He had 3 C's, we took 2 out, so that leaves 1 C behind. There you go. Does that make sense? Gosh, I hope so. I really do. Oh, let's do this one. 5x minus 13y. Okay? So look at the 5 and the negative 13. That's, can you divide anything out of a 5 and a 13 other than 1? No. An x and a y. Wait, he's got an x, he's got a y. What? Guess what? It's prime. You can't factor anything out of there. Yeah, those don't happen very often, but they do happen. So now you've seen an example of a prime polynomial. Let's say we do 2 more. Is that fair? Let me pick some longer ones here. Let's jump down to number 19. 14 G H2 plus 28 GH plus 14 H. All right, so now when I look at what I can factor out or divide out, I have to consider all 3 pieces. Start with the coefficients, a 14 and a 28 and a 14. The biggest thing I can take out of those 3 is a 14. A G, no G's. Nope, I can't take any G's out. H2, H, and H, I can pull one H out of each. So what gets left behind? Well, that would leave a 1. I didn't take the G, so it's still in there, and I took one H, which would leave one H behind. Go on to this guy. Divide out of 14, leaving behind a positive 2. I didn't take any G's out. I did take the H out, so he's gone. And moving on here, positive 14 divided by 14 is 1. And I took that H and I took that H, so nothing there. So guess what? Here's a really good example of when you do need to show the 1, right? Because if you said a 14 divided by 14 is the invisible 1, and then the H divided by H is invisible, then you would have nothing here. And you need that 1 there almost as like a placeholder. So that if you were to try to redistribute this or to multiply, you would remember that there isn't that 1 out there, so that 14H times 1 would become 14H. So that's kind of, I guess that's one of the reasons I'm a fan of showing that 1 when you do your division. I know technically you don't need to show an invisible 1, but sometimes it ends up really not being invisible, okay? What do you think? Let's do one more. I'll pick the hardest one I see. How about that? And if you can stick with me on this one, I would say you're good to go. Let's do 24. It's 3. A to the third, b squared c, minus 9, a squared, b3, c2, plus 15a, b4, c3. Piece by piece. Don't let how it looks overwhelm you. Okay. I've got a 3, a 9, and a 15. The biggest thing that can come out of there is a 3. A3, A2, and an A. Well, the most I could take out is 1A. B2, B3, B4. How many? What's the most I could take? He could give me 2, he could give 2, and he could give 2. So I can take 2 out. A C, a C2, and a C3, I can take 1 C out. Okay, here we go. What gets left behind? A 3 divided by 3 is a 1. A3, I took 1 out, leaving behind a 2. B2, I took both out. C, I took it out. So the first piece, all that's left behind is a 1A squared. Move on. A negative 9 divided by 3 is a negative 3. A2, but I only took 1A out, leaving behind an A. He had B3, I took B2 out, leaving behind a B. And he had C2, but I took one of those C's out, leaving behind a C. On to the last piece. A positive 15 divided by 3 leaves a positive 5. He had an A, I took it out. He had 4 B's, I took 2, so that leaves 2 behind here. He had 3 C's, I took 1 out, leaving behind 2 C's there. Boom! You just factored a pretty long trinomial. That is awesome! Now, I just hope you understand it. What if you don't? What if you don't understand it? Oh, should you just sit there and like dig your heels in and have a fit and cry and beg your parents to try to understand it? No, your parents aren't your math teacher. I am. So if you're struggling, reach out to me, right? Remember, I'm asking you to try to do this stuff. It's not the same because we're not together. Email me and let me know that you're struggling. We can set up a Google Meet time where it's just maybe you and me or you and me and a couple other kids that are struggling, and we'll try to do some of this stuff in real time where you could ask me questions like, Lesnar, how in the world did you end up with a negative 3 there? And I could probably explain it pretty quick to you. So do not sit there and struggle and suffer and make everybody in your house suffer. It's ridiculous and it's not worth it, right? I don't want you to become frustrated. There, I've said what I wanted to say. All right, so take care, be well, and I don't know, I won't see you soon, but we'll be in touch, okay? All right, guys, bye-bye.